Hi, my name is Steve Williams. I'm here today with David Pesci, and we're talking about the use of XRF for lead analysis, for lead inspector training purposes. David, do you want to care to tell us a little bit about what you do as a lead inspector?
Hi. So today I have here an XRF analyzer, which I use all the time for testing for lead paint, both doing inspections and now doing new RRP assessments for contractors. Having taught hundreds of contractors, I know that some of them are very uncomfortable using the chemical tests that we teach them how to use every day. And while we spend only a few minutes showing them and they're allowed to use it, they feel like their liability may increase by testing for lead paint, and they don't feel comfortable with the results. And so that opens up a big field for inspectors now to be able to use a much easier and more accurate, sometimes, machine such as XRF.
So most lead inspectors are using X-ray fluorescence now as opposed to the chemical test?
That's correct. Most, if not all, inspectors have access to an XRF. Only a very few states, including this state, Massachusetts, allows inspectors to use a different chemical test when doing inspections. But for the most part, there's no reason why any inspector should not have access to and use an XRF analyzer. It cuts down the inspection time tremendously, and you can feel more comfortable with the results at the end. You don't have to feel like you're cutting corners.
So the reason people use XRF is because of the speed of the measurements and also the accuracy of results?
That's right.
Okay.
Today I'm going to be showing you a few of the functions and uses of XRF analyzers that I use all the time for doing lead paint inspections. In addition to doing lead paint inspections, I'm also an instructor for the EPA's RRP course. And that course I've taught hundreds of contractors how to follow lead-safe practices and also how to test for lead paint using chemical tests. Now, some of them, if not many of them, have come to me and said that they don't feel comfortable doing their own testing for reasons that we've only trained them for only a few minutes on how to use it. They don't feel comfortable since they don't have the proper insurances, and they feel like there's a big liability that's been opened up for them. And so this may open up a large field for lead inspectors to perform these inspections for contractors. And one of the best methods for testing for lead paint is XRF analysis. And I know almost every inspector has access to an XRF. Most of them are required to have it. And it gives fast, accurate results, and you don't have to worry about if you've cut into the surface properly. You don't really have to worry about too much, and there's no reason to cut corners. So today, I'd like to show you a little bit about my machine here, and a few features of this machine. You'll notice right on the front here there's this orange button. This is called the proximity button. This is very important because when this proximity button is pushed in, it opens up the shutter inside, which exposes the radioactive source. And this allows us to measure for lead paint. So it's important that this not be pushed unless you're ready to take a result. And while it's closed, it's very safe. As I mentioned, there's a shutter inside this machine. This will open and close to expose the source when this button is pushed, and also the trigger is pushed. On the top, we have a display screen. This will give us information about the results we're currently measuring, the time we've measured, and it can also use it to go back and check old results if you want to. A few other things: we have a battery. This is important, make sure it's charged. And also we have the trigger here. This trigger is going to be how we operate the machine in conjunction with the proximity button. Okay? So the first step when you take the machine out of the box is to turn it on and let it calibrate itself. Once it's calibrated, you're going to go ahead and check that calibration to make sure that the machine is fit for use. So the best way to do that, or I should say the way to do that, is these are called NIST standards, and they're for lead paint. And we have a variety of them here today. They're all different colors, so you can choose by color. The HUD requires that we use this standard here, this orange one. This is a 1.04 standard, and that's the one we're going to use today. Now, you can buy these standards. They're fairly expensive, but another great feature of my machine is that it comes with this nice calibration sheet. So we can use it, and we have that same color right here, orange. And we're going to use that standard to make sure that the machine is fit for use. So we'll take the machine, and we will place it firmly onto that standard. And we'll pull the trigger. Another great feature about this machine is that you can actually release the trigger once you pull it, and it will continue to take the result. As long as you see those orange blinking lights, you'll notice that the machine is still operating. Once those go away, you may also hear a sound of a shutter closing. That means that it is no longer taking a measurement. You'll also hear a series of beeps throughout while we're taking this measurement. It should beep every 5 seconds that we're taking measurement, and it'll also beep twice when we come up with a final result. When you're checking the calibration, you should do it for at least 20 seconds, and that way you'll be certain that you have an accurate result. And once we have that result, we're going to compare that to what we have is called a performance characteristic sheet, or a PCS. All right, so I've actually taken that measurement for 24.8 seconds, and my result was 1.0. So we have that result. We'll go and we'll check out our PCS here, and it says that our limit should be between 0.8 and 1.2, and 1.0 is right in the middle of that. So you can see here that our machine is now fit for use, and we can go and do our inspection or whatever you're going to do with it. XRF is an important technology because it can safely and accurately give you results of lead paint in a home. And there's a lot of talk these days about healthy homes, and remember that a healthy home is a lead-safe home. Here we are in a residential apartment, and we will be doing some lead paint testing here. Right now we're in the kitchen, and you can see behind me that we have 2 windows that have been replaced with vinyl replacement windows. This is pretty typical, especially around here in this area. You notice from the windows that we have several different paint histories. Now obviously the vinyls themselves will not have lead paint on them, but the stops look fairly new, and the casing, the sill, and the apron all look fairly old. But we're going to test each component to make sure that the paint histories are in fact different, and we can check the different results. We'll start with this window. We'll have casing, we have stops, we have a sill, and we have an apron. And each component should be tested individually because the paint histories can vary. You can see that since these vinyls were put in, they look fairly recent. These stops are also new. That's not always the case. Sometimes the stops are reused, so you want to test them to make sure. They may not match the results of the rest of the window. I like to start with the casing. You find a flat spot on the casing, push, pull the trigger, and now you can see that the machine's lit up. It's already giving me a result in a matter of seconds. 0.15, so that is far below the standard of 1.0, but again, it's not 0. So we're going to want to test the rest of the window. We can move on to the sill. You can do it by either testing on the flat up here, or sometimes you may find it easier to test on the edge of the sill. We have 0.02. So we can move down now to this apron. Should have a result fairly quickly, and there it is, 0.01. So once again, it is very low. Now if we move to the stops, we once again got 0.00. So these stops, as I said, are brand new and shows that there's no lead paint on them. Now we can move on to this door. So this door looks to be fairly old, all the components do, and we're going to have to test several parts of it to make sure because the paint histories can vary. So to start, you can test the interior part of the door, and hopefully we will get and we have a result. It's lead safe. Well, now we can move on to the casing here. So the casing looks similar to the windows, but we don't know for sure. It's below the standard, it's lead safe. And now this is the jamb, the inside part of the door. So this is the interior part of the jamb, which may vary compared to the outside, but we got a number of 15, which means that this is 15 times higher than the standard. It is not lead safe. So even though the inside casing was okay, as soon as we got to the jamb, we have lead paint above the standard. You can see that in this old apartment that we have a variety of components, both old and new, with various paint histories. And by using portable XRF technology, we can both quickly and accurately evaluate these surfaces to see if they're lead safe. And at the end of the day, you can do this in a way that you can feel comfortable with.